Hello everyone, welcome to the channel first of all. And before starting the topic, I just want to ask you two questions. What exactly is motion and why do we need reference points? Okay, so in this video we will start ICSE class 9th physics with the most important chapter, motion, and I'll try my best to make you understand it in the simplest way possible. Starting, what is motion? Right? What is motion? In very simple words, motion is nothing but change in position with time. Let me tell you a simpler definition. Motion is actually the change in position of an object with respect to time. Now imagine this, you're sitting in a moving bus, right? Are you moving or not? So relative to the bus, you are at rest, right? Relative to the road, you're moving, right? So if a person is standing on the road, to him you are moving, and if the person is standing stationary on the road and you are in the bus, to you he is moving. I hope this makes sense, right? So motion always depends on something which is called a reference point. Okay, now coming to types of motion. Now we know what motion is. Now we come to something called the types of motion, right? Types of motion, right? So let's look at the main types of motion, that you need to know from an exam point of view. So we have translatory motion, right? So in translatory motion, if you have an object, right, this object moves from one place to another, right? Okay, it moves from one place to another place. Its position shifts, right? So translatory motion is again divided into two main parts, right? Rectilinear and curvilinear, right? So rectilinear is this object moves from position A to position B in a straight line, right? And when the same object moves from point A to point B in a curved line, it's called curvilinear motion. So easy way to understand translatory motion: an object moves from one point to another point. If it moves in a straight line, it's rectilinear. If it follows a curved path, it is curvilinear. Okay. Now coming to the second type of motion, which is called the rotational motion, right? Rotational motion. Okay, so the name itself gives out what type of motion this is, right? In rotational motion, an object moves in a circle or about an axis. So you have an axis, right? And an object moves around a fixed axis, right? So it basically rotates, right? Rotational motion, it rotates. Okay, so we have examples. Examples are your ceiling fan or the earth rotating, right? You might have studied in your smaller classes that earth rotates around an axis, right? Yeah. So we have a third type of motion now. Third type of motion called the periodic motion. Pretty interesting type of motion, if you ask me. Okay. So what does periodic motion mean? A motion that repeats after equal intervals of time. Okay, equal intervals of time. Okay, for example, you have pendulums, right? You have swings. Okay, so an object moves from one point to another point in 1 second, comes back in 1 second, goes back in 1 second. So this is very periodic. Okay, so far we have gone through the definition of motion, okay, types of motion, with examples. Okay, now moving ahead, let's come to this part, right? The most important part of all, distance and displacement. Okay, right? So I hope you guys know what distance is, but displacement could be something that you're hearing for the first time, right? In simple words, when an object displaces from its original position, it's called displacement. Okay, I'll come to it, right? So in many cases, students usually get confused here. Okay, so distance. Okay, let me just erase this. Okay, so let's say what distance is. Distance is the total path covered by an object. Okay, so you have an object, it moves in whichever path. Okay, so you just measure the length of the path it takes. Okay, and the measured length is called distance. Okay, and it has two properties, which are it is a scalar quantity. A scalar quantity is a quantity which has no direction. Okay, and it is always positive. Okay, you cannot have a negative distance. Distance is always a positive value, right? For example, if you walk 10 meters, right, 10 meters forward and then 5 meters back, 10 meters forward and then 5 meters backwards, so your total distance will be 15, right? Okay, now coming to displacement. So what do you think displacement is? It is the shortest path. For you to remember it and understand it in a simpler way, it is the shortest path. Okay, shortest path. So an object displaces from one point to another point, right? The shortest path followed by it is the displacement. Okay, let's go up and let's see. In this path that I have drawn, we know what the distance is. It is the total path covered. The displacement will be this. I hope you guys understand now. So the displacement is the shortest path, not the entire path or the total path. Okay, so important property of displacement is it's a vector quantity, which means it has both magnitude and direction. Okay, for example, you move 10 meters forward and 5 meters backwards, so the displacement is 5, because the shortest distance between your starting point and your ending point is 5. Okay, so another thing for you guys to consider is you have to always see the start point and the end point when calculating displacement, because the path can be however, right? But what matters is the starting point and the ending point, only in case of displacement. When it comes to distance, you have to measure the entire thing. Okay, and one key point is distance can never be 0 if you move. Okay, but displacement can be 0 if you move. Okay, for example, you move from this point and you come back to the same point. In this case, the distance is whatever the path covered. Okay, and the displacement is 0 because you come back to the same point. Fine. Now coming to the next part, which is speed. Okay, not ISO speed, but actual speed. Okay, in this chapter. So how do we define speed? Speed is nothing but distance by time, or in other words, the amount of distance covered in a certain amount of time, or the amount of distance covered per unit time. Okay, and what does speed tell us? It tells us how fast something is moving. Okay, right. So speed tells us how fast something is moving. So again, we have types of speed as well. You have uniform speed types. So you have uniform speed, okay, which is throughout the path carried by an object, the speed is the same, doesn't fluctuate, it doesn't change, it remains constant. Okay, and then you have non-uniform speed. Okay, the speed keeps changing, so it's 10 kilometers per hour, then 8 kilometers per hour, then 16 kilometers per hour. I hope you get my point. Okay, for example, let's take an example. If a car travels 100 meters in 10 seconds, okay, the speed is distance time, so it's distance by time, which is 100 by 10, which is 10 meters per second, or in other words, the car moves 10 meters in 1 second. Okay. In this particular class, we have basically covered the basic aspects of motion, right? Motion, distance, displacement, and speed. Okay, now coming to something which is called velocity, right? Velocity is nothing but displacement by time. Right? So it's basically similar to speed, or in other words, it's a vector version of speed. So in speed we consider distance, in velocity we consider displacement, as velocity is a vector quantity, which means it can be negative, it can be positive, right? For you guys to understand this in an even clearer way, velocity is shortest distance by time taken to cover that shortest distance. Okay, all right. Now we have covered speed and velocity. Okay, now let's cover acceleration. Take a pause and try to think what acceleration is. You would have heard this particular word in many places, especially when it comes to cars and automobiles, right? So what is acceleration? Okay, acceleration is change in velocity with respect to time, right? In other words, change in velocity divided by time, right? So an object can have varying velocities, right? But what do we consider mostly? We consider the initial velocity, usually denoted by u, and the final velocity, usually denoted by v. And how do we calculate acceleration? We find the difference in the initial and final, right? So final velocity minus initial velocity divided by time is acceleration. Okay, so if velocity changes, acceleration exists. If velocity does not change, then acceleration is 0. Okay, so basically acceleration is not just speeding up. Okay, it happens in 3 cases, right? You have a car going from 10 meter per second to 20 meter per second. In this case, the acceleration is positive because the velocity is increasing. Now consider the car is moving from 20 meter per second to 15 meter per second. Here we have negative acceleration because the velocity is decreasing. Okay, if a car uses brakes slowly, we see negative acceleration, and for accelerators, positive acceleration. Okay, so now we have a third case as well, when direction changes. Okay, so if the speed is constant, changing the direction also means there is acceleration. For example, circular motion. For example, a car is moving in a straight line and takes a turn. In this case, there is acceleration, right? So when a car takes a turn, there is also a change in velocity, right? Because this can be the distance, but this will be the displacement, right? And velocity is change in displacement by time. Okay, fine. Now we have the unit of acceleration. Unit of acceleration is meter per second square. Okay, so which means that velocity changes every second. So that is why we have meter per second square. Okay, now let's go through all the units. So we have distance and displacement. The unit is meters. We are talking about SI unit because that is the most commonly used unit, is meter. For speed and velocity, we have meter per second because distance by time. And then for acceleration, we have meter per second square because velocity by time. Okay, change in velocity by time. Fine. So that's it for today. Okay, if you found this video really helpful, like the video, share it with your friends, and subscribe this channel for more such videos. We will most probably go through further topics as well as numericals on the same subject. Okay, thank you. See you in the next one. Bye bye.